For our design, we decided on a differential gearbox. In this setup, there are two inputs into the differential with a ratio of 1. The carrier spins at the average speed of both inputs. Therefore, when one input is at rest, the output speed is 1/4 the input. And this is true for both sides. When moving in the same direction, the output is half the average of inputs due to the reducing gear. When both inputs are equal but opposite, the output is 0 RPMs.
As explained in the video before, this video shows one input set at 0 by being held still, and the other at around 800 RPM. In this setup, the output would be the average of the two inputs divided by 2, which obviously is 800 and 0, so the average out of those two would be 400, and then half of that because it's the differential gear, so you're going to get an output of about 200 RPM, as you can see. For our design, we decided on a differential gearbox. In this setup with two inputs, the output is equal to the average of the inputs divided by 2. So in the video you're seeing right now, the left drill, the tachometer read the first two readings on the video were 329 and 307, and then we read the right drill, it was more around 250 RPM. So the average of 329 RPM and 250 RPM as the input is about 280, so our output theoretically should have been about half of that, obviously 280, 140. So if you see in the video, the first reading the tachometer gives of the output shaft is actually 144 and then 181. Obviously this is not a controlled setup, so there's some room for error. Right now on the screen you can see the equation and the formulas we use to actually work out this problem ourselves. In an ideal scenario, both inputs would be 1000 RPM, and then if you find the average of both of those, obviously it's 1000, which is also the RPM of the carrier, and then to get the output speed, you just take half of the average of the two inputs. So 1000 and 1000, the average of that is 1000, and then you take half of that, so the output speed should theoretically be 500 RPM. And the last video we're going to show you today is that if you have both drills or the input shafts going in opposite directions but having the same revolutions per minute, the carrier and the output shaft will actually just have a RPM of 0, and they will just not be moving and rotating. As you can see, we tried showing for as long as we keep the inputs the same revolutions per minute.